All right, diving in today, we've got this new report from the Anthropic Economic Index. And, they're always looking at AI and the economy, but this time they're really honing in on Claude 3.7 Sonnet, that big update, and trying to figure out, what it means for us, for the workforce. And we're going to, like we always do, pull out the most interesting stuff, the stuff that really matters, especially for those of you who really like to dig deep, get into the nitty gritty.
Yeah, absolutely. The Anthropic Economic Index, it's like it gives us this data-driven window into how AI is shaking things up, economically speaking. And with this report, we're going deep on Claude 3.7 Sonnet, understanding the changes it's brought about, the technical side of it all, and, what it means for the academic world, for research.
So let's break this down, put on our researcher hats for a minute. Two data sets, right? First one, December 2024 through January 2025, pre-Sonnet. Then, boom, Sonnet drops. Second data set, 11 days in March 2025, right after. They're mapping, get this, anonymized user conversations with Claude to specific tasks. And where do those tasks come from? One head.
And that's crucial, that choice of OneIt, because, not everyone's familiar with it, but it's this massive database, categorizes occupations, every job you can think of, breaks them down into tasks. So by connecting AI usage data with this really structured framework, Anthropic can really analyze how AI is being used across the entire job market. It's more than just anecdotes, it's a systematic approach.
So where are we headed with all this researchy stuff? First, we'll look at how different job categories are using AI, the changes there. Then into the deep end, extended thinking mode in Sonnet, what it is, who's using it, and what that tells us. And finally, the big question, right? AI, augmentation tool or automation agent. We'll look at that across different jobs, really dig into the academic side of things, the implications.
Exactly. We're going beyond just describing what the report says, We're going to explore what it might mean, the interpretations, why it matters to the research world.
Okay, so first up, changes in how different job categories are using Claude after Sonnet's release. What are the big trends?
Well, the report shows some, not huge, but noticeable shifts in usage patterns, more AI interaction happening around coding tasks, also in education and science fields after they made Claude 3.7 Sonnet the default model.
Can you break that down a bit further, the numbers? What were the percentage changes in those key one-at categories, the big ones?
Let's see, looking at the data here. So computer and mathematical occupations, they went up by 3.0% in terms of their share of all Claude usage. Education, instruction, and library, they saw a rise of 1.8%. And life, physical, and social science, they went up a bit to 0.5%.
And on the flip side, any categories where Claude usage went down during this time?
Yeah, a couple of dips: arts, design, entertainment, sports, and media, that whole category down by 0.7%. And office and administrative support saw a reduction 0.8%.
Now let's think about this like academics. Increased computer mathematical usage. That makes sense. Sonnet's better at coding. But the increases in education and sciences, any theories there? What might explain those?
There are a few ways to look at it. One possibility, right, is just more people in these fields are using this more powerful AI model, realizing they can use AI in their work. Another idea is that we're seeing new ways to use AI in these fields, maybe because Sonnet's coding abilities open up new possibilities for specific tasks. Or maybe, Sonnet has some hidden talents, some capabilities we didn't expect that are proving really useful in these knowledge-heavy areas, and that's driving adoption.
Makes you think, right? It's not just about how powerful the AI is, but how well it fits the needs and the way people work in different fields. And the report emphasizes that these trends, these weren't just blips. They stuck around, didn't they?
Right. The researchers, they found that these overall trends, more use in computer science, education, and the sciences, less in arts and media and office support, they held steady for 2 whole months between the first and second reports. So it's looking like these are real shifts, not just random fluctuations.
Okay, let's shift gears into extended thinking mode. Now, this is getting a bit technical, but what is this extended thinking thing in Sonnet, and what does it tell us about how people are using AI to solve tough problems, from a research perspective?
So extended thinking, it's like a turbo mode for Claude 3.7 Sonnet, uses more computing power, but the user has to turn it on. It's for when things get really complex. Basically, it gives the model more resources, more time to think, dig deep, analyze things thoroughly. Imagine it like the AI gets to take a long, hard think about the problem.
So people are choosing to use this extra power for certain types of tasks. What occupations are really into this extended thinking mode, and what does that tell us?
The report says it's mostly used for, technical, creative problem solving. They've got data on the top occupations using it and how much their thinking fraction went up after Sonnet's release. Now, thinking fraction, that means how much of the time they spend with Claude is with this extended thinking mode activated.
So who's really pushing Sonnet to think hard?
At the top, computer and information research scientists, their thinking fraction jumped up by 9.7%. Then software developers, system software, they're at plus 8.0%. Multimedia artists and animators, they're around plus 7%. And video game designers, about plus 6%.
Makes sense, right? Those are all fields with, complex technical stuff, lots of creative problem solving. They need that extra horsepower. It's not just about using AI for simple tasks. It's about using it for deep thinking, the tough stuff.
Yeah, exactly. It suggests they're using this mode when they hit a wall, a problem that needs real analytical power. And what's really cool, Anthropic has actually made their data set public, the one linking one tasks to this thinking mode fraction. So researchers can really dig in, study exactly what kinds of problems are driving the use of this more intensive processing.
All right, augmentation versus automation. Now, the report says the balance overall pretty much stayed the same, but things got interesting when they looked deeper, right? Let's talk about what these terms mean, when it comes to interacting with AI and what kind of shifts happened in those specific categories.
Okay, so augmentation, that's when AI helps us, makes us better, like a partner. Automation, that's AI doing the work, without much human input. The big picture, 57% augmentation, so that's still the main thing. But inside those categories, there were some pretty big changes.
Break down those changes for us and what they might mean from an academic perspective.
So first up, interactions way up from about 23% to 28% of all the conversations. What does that mean for researchers? Well, it looks like more and more people are using AI to learn stuff, to gather information, understand complex topics. Like they're seeing Claude as a teacher, a research assistant.
Interesting. AI's role in how we learn, how we develop professionally, that's a big deal. What about the other types of interaction?
Task iteration, that's about working together with AI, going back and forth to create something. That one went down 31.3% to 24.8%. Now, the report doesn't really say why, but maybe people are using AI more directly now, or maybe they've figured out more efficient ways to use it for these iterative tasks.
And for automation, what happened with directive and feedback loop automation?
Directive automation, that's when you tell the AI what to do and it does it. That went up 27.8% to 30.4%. Maybe people are getting more confident that AI can handle certain tasks on its own, like translation or writing a first draft. Now, feedback loop automation, that's AI finding and fixing problems on its own, that one dipped a bit, 14.8% to 12.7%. Why? That's a question for researchers to explore.
So augmentation is still king, but the way we're using AI is changing. Okay, let's zoom out, look at these patterns across different types of jobs, big picture stuff.
So the report breaks it down by those big WONET categories, remember? Community and social service jobs, they're using augmentation a lot, like 75%. What does that tell us? It's about enhancing human skills, not replacing them, in jobs where you need empathy, good judgment, like counseling, social work.
AI as a partner in people-focused jobs, that's a powerful idea. But what about more technical jobs, jobs focused on output, you know?
Production and computer and mathematical, those are closer to 50-50. Augmentation and automation. That's where things get really interesting for research. The balance between working with AI and letting it work on its own in these specialized fields. AI can be a tool and a doer. It's a dynamic situation.
And to be clear, no job category had more automation than augmentation, right?
That's a key point. Automation is growing, for sure, in certain tasks. But across all those major job categories, it's still augmentation, humans and AI working together. That's dominant.
Okay, let's get specific. Paint a picture. The report has some examples of how this is playing out in real jobs.
Okay, let's see. Task iteration for copywriters, 57.7%, and editors, 54.8%. That's where it's big. What does that tell us? AI is becoming a partner in creating content, helping with drafts, refining text. It's a back and forth.
That's a great example of how AI is changing creative work. What about directive automation? AI doing the work directly.
Interpreters and translators, they're at 58.6% for that. So AI is being used to actually produce translations, less direct human involvement.
And how about validation augmentation? AI helping to catch errors.
So quality assurance engineers and testers, they're at 10.7%, and statisticians, 9.4%. AI is helping to ensure quality, accuracy in software and statistics through automated checks.
Learning augmentation, AI supporting learning and analysis. Who's doing that?
Librarians, 55.9%, computer hardware engineers, 55.5%. So in fields where things change fast, there's lots of data, AI is really helping with research, finding information, analyzing it.
And lastly, feedback loop automation, AI fixing problems on its own. Where's that happening?
Network and computer systems administrators, 44.9%. Web administrators, 41.0%. They're using AI to monitor systems, find problems, and fix them automatically. Keeps things running smoothly.
Now, the report visualizes all this in a chart, right? What does that chart show us?
Yeah, automation versus augmentation by occupational category, that's the one. What's interesting, the computer and mathematical category, it's got a good chunk of both directive and feedback loop automation, along with augmentation. So like we said, it's that balance, humans and AI working together and AI working solo, especially in those technical fields.
This gives us a much clearer picture, right? It's not just about AI taking over jobs. It's about how it's woven into different roles, the nuances. Now, this bottom-up taxonomy, that's new, right? Why did they do this, and what's the big deal for researchers?
They wanted to go deeper, OneNet, it's great, but it's based on existing job titles. But with a general purpose model like Claude, people are using it for all sorts of things that might not fit neatly into those job categories. This bottom-up approach, it's about seeing what's actually happening, not just what we expect to see.
So instead of starting with job titles, they looked at what people were actually doing, right? Grouped similar activities together.
Exactly. They call it first of its kind data sets, 630 clusters, very specific, and they use the same anonymized conversation data as the OneNet analysis, so you can compare them.
Pretty innovative, right? It's like a map of how people are really using AI, more detailed, maybe more accurate. Can you give us some examples of these clusters? What do they look like?
Let's see. One is help with water management systems and infrastructure projects, very specific. Another one, create physics-based simulations with interactive visualization capabilities, pretty technical. And then one that's more relatable, help me create or improve job application materials.
Those examples really show how this bottom-up view can reveal new, maybe unexpected ways people are using AI. What kind of information is in the data set about each cluster?
Each cluster has a description, how common it is, and importantly, how much is augmentation versus automation. So it gives us a much richer picture of what's happening, the variety of ways AI is being used.
This bottom-up taxonomy, it seems like a big step forward for AI research, getting closer to the reality of how it's being used. Okay, let's wrap up. What are the key takeaways from this report, the stuff that really matters for academics?
Okay, big picture. Specific changes in how jobs are using AI after Sonnet, with more use in technical and knowledge-intensive areas. Extended thinking mode, mainly for complex, technical, and creative stuff. Implementation is still the main thing, but learning interactions are way up. And this new bottom-up taxonomy, that's a new tool for understanding the many ways AI is being used.
All right, for our listeners who really like to think about the big picture, a final question to ponder.
Here's something to think about. We see this trend, more reliance on AI for learning, more focus on complex thinking. How might this change what it means to do knowledge work, in the long run? What skills will we need? How will education need to change? Those are big questions. And if you want to explore them further, Anthropic has made their datasets public. You can find them on Hugging Face.
Something to chew on, for sure. It's clear that we need to keep looking at the data, keep analyzing these trends to understand this constantly evolving relationship between humans and AI. Thanks for joining us for this deep dive. We'll catch you on the next one.